Hello friends, this is Bharti and you are watching Learn Maths with Bharti. Today we are going to learn a new topic, proof of Pythagoras theorem. And it is very important for class 10 students. CBSE has been deleted this topic from NCERT, but this theorem is very important for AP Board and other boards. So let's get started. So friends, I have already created some videos on similarity of triangles, AA similarity, SSS similarity, SAS similarity. If you have missed those videos, please go and check it out. For that, I will put the video link in the description box below. If you watch those videos, that will be helpful to you. So friends, here we have Pythagoras theorem. And I'm sure that you all are familiar with the statement of Pythagoras theorem because in the earlier classes you have used this theorem many times in solving some problems, and I hope that you have proved this theorem through some activities also. So here also we are going to prove this theorem but in different way. Okay, so let's read the statement. In a right angle triangle, the square of the hypotenuse side is equal to the sum of squares of the other two sides. So to prove it, first we need to draw a right angle triangle. So let us draw a right angle triangle ABC, which is right angle at B. Okay, so write the same thing in given. Given a right angle triangle ABC where angle B is equal to 90 degree. So what do we need to prove? We need to prove that hypotenuse square is equal to side square plus side square. Clearly you can see here that AC is the hypotenuse, so we have to prove that AC square is equal to AB square plus BC square. We have to prove it. Now, how we will prove it? We will prove this theorem using the similarity of the triangles. For that, to use the similarity, we need at least two triangles, but here we have only one triangle. So, we need to do some construction. So, what is that? Let us drop a line. Let us drop a perpendicular from point B on the opposite side. It means on the hypotenuse. Let us drop a perpendicular from B on AC, which is BD. Now this angle will be 90, this angle will be 90 degree. So what is the construction? Draw BD perpendicular to AC. This is the construction. Now we will prove it. Now we will start the proof. For that, we will choose two triangles first. First we will choose two triangles ABC, which is big triangle. Let us mark it with yellow color. So ABC is a big triangle which is right angled at B. Okay. Now we will choose one more triangle, left side triangle, small triangle ADB. In triangle ADB, angle D is 90. So we will prove that this yellow triangle and green triangle, these two triangles are similar to each other. Okay. So now once you recall the similarity criteria, AA is enough. Okay. First we will search for any two angles, any two corresponding angles. So here we have two triangles, one is big and one is small. So here it is confusing, but try to understand, okay, because small triangle is like this straight and position of triangle ABC is different. So try to see here which is corresponding to which angle. Okay, in small triangle ADB, angle A is there, okay, and in big triangle ABC also angle A is there. Okay, in both the triangles angle A is common. Okay, it means one angle we have found out. One angle is common. Search for another angle. Since it is a right angle triangle, ABC is a right angle triangle, right angle at B. So in big triangle angle B, and in small triangle in ADB, we have dropped a perpendicular now. So angle D is equal to 90 degrees. So this angle is 90 degree. Here this angle is 90 degree. So here in small triangle angle D, and in big triangle angle B. These two are equal because each is 90 degree. So one more angle is equal. Okay, so here corresponding two angles are equal. So by AA criterion we can prove that these two triangles are similar to each other. But we have to write the triangles in order. See, in triangle ADB, and okay, A is common, so big triangle, see the order how I am writing for the big triangle. First I have to write A. Okay, I have written ADB here, so here A is corresponds to A, so A, and here D is 90 degrees, so here we have to write for big triangle B is 90 degree. Now write the remaining angle C. Okay, so this is the correct order. In triangle ADB and triangle ABC, angle A is equal to angle A. What is the reason? Right? Common. Okay, and in small triangle ADB, we can write angle ADB is equal to, in big triangle we can write angle ABC. Each 90. What is the reason? Each 90 degree. So therefore by AA similarity, triangle ADB is similar to triangle ABC. Okay, we have proved it. And now we have proved that these two triangles are similar, so we can equate the ratio of the corresponding sides. It means corresponding sides are proportional. So here it will be confusing to see the corresponding sides in the figure. So you choose the we have written this, see, we have written this similarity in an order, so we can choose the corresponding sides from here. See, here AD, see here AD by AB, we can write AD by AB. Okay, so therefore we can write AD by AB, and see AD by AB. Now DB by BC, so we can write is equal to DB by BC is equal to, one more is there here, what is that? AB by AC. We can write AB by AC. Okay, why? Because sides are proportional. Here sides are proportional, but we need only two ratios. Okay, choose those ratios from which we can get this, AB square. Okay, AB square. We want AB square. So which two ratios we have to choose? Here we can see AB. Here also we can see AB. So select these two ratios. So we can write AD by AB is equal to AB by AC. Okay. So cross multiplication, AD into AC is equal to AB square. AB into AB is AB square. So this is, mark it, equation number 1. Now we will continue in the next slide. So here also we have to prove the two triangles similar. Green triangle, right side triangle, triangle BDC, and big triangle, triangle ABC. So here clearly you can see that angle C is common to both the triangles, and one angle is 90 degree. In green triangle, angle D is 90 degree. In yellow triangle, angle B is 90 degree. So by A similarity, we can say that the two triangles are similar to each other. So here order is very important. Okay, so here how I am writing, once look carefully. In triangle, and here also I will write triangle. Now this order is very important. Here one angle is common. Which angle is common? Angle C is common. Let us write angle C at the end in both the triangles. Okay, I am going to write the green triangle on left side, and I am going to write yellow triangle on the right side. So which angle is 90 degree in green triangle? D. And which angle is 90 degree in the yellow triangle? B. Now which is the remaining angle of green triangle? B. And which is the remaining angle in yellow triangle? A. So this is how we should write the order of the triangles. Okay. So here triangle BDC, in triangle BDC and triangle ABC, angle C is equal to angle C. And you mention the reason here, common angle. Now in green triangle, angle BDC is equal to, in the yellow triangle, angle ABC. Now what is the reason? Each 90 degree. Clear? So therefore by AA similarity, triangle BDC is similar to triangle ABC. Okay. So you know that in similar triangles the corresponding sides are proportional. So now we have to write the proportionality. Okay. But from the figure it is difficult to write the sides in proportion. So here we see here, we can write from here BD. See here BD by AB. Okay, we will write BD by AB is equal to, we can write DC by BC, DC by BC is equal to, see here we can see BC by AC, BC by AC. Why? What is the reason? Proportional. It means why we are writing, because in the similar triangles the corresponding sides are proportional. So here, but we need only two ratios so that we could find this one. See in the last slide. Here we want BC square. Okay. So from which two ratios we can get BC square? See here, this one and this one. Okay, if we cross multiply we can get BC square. So write these two only. Therefore DC by BC is equal to BC by AC. Now cross multiply, you will get DC into AC is equal to BC square. Now this is equation number 2. Okay. So in the previous slide we have marked the equation number 1. Here we have equation number 2. Now adding equation 1 and 2. Adding equation 1 and 2. We get left hand side and left hand side will be added. It means in the last slide we have AD into AC, then plus. Here in equation 2, DC into AC is equal to, in equation 1, AB square. Now what is in equation 2? In right hand side, BC square. Now here what is common? You can see here AC is common. So AC, take AC common, we will get AD plus DC inside is equal to AB square plus BC square. So here you can see that AD plus DC, AD plus DC, AD and plus DC is what? AC. So AC into what is AD plus DC? AC. It can be written as AC is equal to AB square plus BC square. Now AC into AC is what? AC square is equal to AB square plus BC square. So we have proved. Okay, hypotenuse square is equal to side square plus side square, hence proved. So friends, I hope you have understood clearly today's topic. If still you have any doubt, you can comment in the comment section below. So friends, I have already created some videos on similarity of triangles. If you have missed those videos, please go and check it out. For that, I will put the video link in the description box below. If you watch those videos, that will be helpful to you. And if you are new to my channel and you like my videos, then please like, share and subscribe. And I will meet you in the next video. Till then, take care and thanks for watching.